All right, let's do some practice combining resistors in parallel and series. So one of the basic rules is if you're not sure what to do, stop doing what you're trying to do. So if you're like, oh, I'm going to connect these all in series. So you're like, okay, so that's 25 plus, oh man, I don't know what to do. Once you hit the I don't know what to do phase of the problem solving strategy, that means stop what you're doing and try to do something else. So even though you might want to try to combine this in series with all this, if you get to a point and you're like, I'm not sure what to do, take a look at the subset of what you're looking at. So for example, here we have three things which are clearly, I love that word, clearly in parallel. I mean, they look like they're in parallel, but they are in parallel because here's a big chunk of solder here, and here's a big chunk of solder here, and all the resistors share the same two chunks of solder. All right, so they all share the same nodes. So I know that for things that are in parallel, the equivalent resistance is going to be 1 over 100 plus 1 over 50, and now here somebody's being obnoxious because that's kiloohms, so that's 1 over 2,000. So I can go and I can throw these into my calculator, and I've got 1 divided by 1 over 100, plus 1 over 50, plus 1 over 2,000. And I get 32.8 or something like that. So 32.8 ohms. Now that makes sense because the 32.8 is smaller than all of those individual values. Therefore, that makes sense. Okay? All right. Now I have these two that are in parallel as well, and the equivalent resistance for them. Gosh, my handwriting is terrible on this new computer. The equivalent resistance for this one is 1 over 2 plus 1 over 10. So 1 over parentheses 1 over 2 plus 1 over 10, giving me 5/3, also known as 1.67. And again, the 1.67 ohms is smaller than any of the individuals. So for me, I usually like to just go ahead and redraw. That way I make sure I kind of remember what I was doing. So I've got 25 ohms, 32.8 ohms, and 1.67 ohms. So that is the same thing as adding those all together. So 25 plus the original value, and I like to go back and use the original value as much as I can in case I end up with a rounding error somehow. So that's 59.5. So that's the same as an equivalent resistance of 59.5 ohms. Okay? So again, when I was going to solve these, I recognized that I had three things that were in series, but within the series, I had two things that were that were connected in parallel. So here's another example that you can try out. I recommend you pause the video and see how much you can figure out on your own. So we'll pretend you've done that, and if not, you've gotten stuck. So you're probably coming around thinking, okay, well, these things are split. Therefore, something must be in parallel. Now, a lot of times students will make a mistake and they'll try to say that this is in parallel with these two. That's not true, okay? Because remember that all these are wires, and the fact that that wire happens to be bent there doesn't really mean anything. I could have had these two on the inner circle just like that, and the 100 and the 20 could have been drawn like that. It would just be like physically taking this one and moving it over here, just making this wire here a little bit longer and this wire here a little bit shorter. So whenever you've split, all right, now little electron guy is going this way and electron guy is going this way. Once he enters the 100, he has to go through the 20. So that means that the 100 and the 20 are in series. Okay, does that make sense? So again, once he enters the 100, he has to go ahead and go through the 20, meaning that the 100 and the 20 are in series. So I add them together. Now, whenever little electron dude goes through the other, makes the other decision, he's got to go through the 10, and then he's got to go through the 5 before he meets back up again. So since he has to go through the 10 and he has to go through the 5, that means that they're joined in 15 ohms. Now, because I've just kind of drawn it nicely, it's pretty clear that these are in parallel. However, it's really important to note that I just happened to draw them nicely because I kind of knew what I was doing, but I could have drawn them like this. I could have drawn them like this as 120 and 15. It's important to note that these are still in parallel because basically I just have a dollop of solder here and a dollop of solder here, so it's a node and a node, And those two exclusively share those two nodes. Both of those start at node 1 and end at node 2. So they are, in fact, in parallel. So the equivalent resistance of these two resistors is 1 over 15 plus 1 over 120. 1 over 15 plus 1 over 120. Might be nice to have an actual plus sign there. And I'll just put period. All right, so I've got a 13.3 ohm equivalent resistor. So I can draw each of those. So first of all, I connected these two here in series and these two here in series. So those two in series became here. These two in series became here. And now the two of those are in parallel to get a 13.3 ohm resistor. Copy? All right, let's try one more. So again, take a look at this problem, pause the video, and see if you can come up with an equivalent resistance. All right, assuming you've done that. Now without too much effort, we can recognize that these are all in parallel. We can also recognize that by just saying there is a giant dollop of solder here, giant dollop of solder that connects all of them on the left, and another giant dollop of solder that connects them all on the right. Since they're all shared by those exact same two nodes, that means that they have to be in parallel. So the equivalent resistance of this guy here is going to be 1 over 1/3 plus 1/2 plus 1/4 plus 1/3. So I've got 1 over 1/3 plus 1/2 plus 1/4 plus 1/3. So 0.706 ohms. And again, the 0.706 is smaller than the smallest number. The smallest number is 2. So basically what I can do is I can rewrite that as a 0.706 ohm resistor and a 2 ohm resistor, which, and I'm just doing this because it's fun. I can clearly add 2. But I have 2.71. Since they're in series, I add them together. A 2.71 ohm resistor. Now there are bazillions of examples of this out there on YouTube. This is just a small version of some pretty straightforward problems, but there's a whole lot more than you can get into when you're looking at these problems going forward.